蔡哥，你每天都这么早到吗？
我就一下课就直接来了。
我每次都是磨叽会儿，磨叽会儿，除非我有问题要问，我就早点来。
你今天是有问题要问吗？
是的，是的。哎，你那个开始做了吗？你那个 college？
没做，本来想今天做的，结果下午睡到5点，然后发现
我也是，我下午也要睡觉，救命了！
想了想还是算了。
我感觉冬天到了就人就容易困，知道吧？然后
对，
我现在统计课上也经常睡觉。
接下来11月份更可怕了。
我去1点半，还好只有135，我好歹6天还能睡个好觉。
下一节课你选的怎么样？
我还没想好，我想把 data structure 和那个1203都选了。
那个时间，data structure 的时间可不是一般人上的时间。
对啊，所以没办法，因为我就算不选那个 calculus 2，还是得就是很晚上，我就想着算了，那就下个学期就消耗一点我的生命吧。
那到时候期待在 data structure 上面见到。
我去，又是那么难的课，然后又要凌晨上课，我乌龙茶都买好了，困死。
乌龙茶很解困嘛。
嗯，
我现在生活也颠倒了，我基本上现在早上6点多睡着，然后早上睡觉，然后下午起床这种。
你下午几点起啊？
下午1点多，就我妈叫我起来吃午饭。
哦，然后你就真的就是晚上就一直在工作。
对，
哦，好惨哦！
乱
我
七八糟的。
下个学期不这样了。
唉，确实就没什么课可以选。
对啊，就没啥课可以选，就没有办法，不然我其实不太想选那么晚的课。
你高一不是上那个，你可以上高二啊。
考二，对啊，是上了考二啊，然后考二
啊你
也是什么
你上了考二了是吧？啊，好吧。
啊啥？我上了考一，没上考二。
我说你下学期是准备上考二了是吧？
嗯，有可能，
啊，那就
还没想好呢，啥都没想，就上次和 Leslie 讲了一下，Leslie 让我上，我就
我明天跟瑞聊，然后我还要申请超过20个学分，
真的啊
就因为
那样
2101多了个。
啊？是吗？210咋了？
2201是5个学分，然后我就超了1个学分。
哦哦，这个居然要申请了。
对，超过20要申请。
那你现在，那你就是21吗？
嗯，
下个学期哦，す
我还
ごい。
怕学校，但如果学校不过的话，我就只能选19。
没关系的，学校肯定会让你过的。
中位数不一定。
真的假的？这个都不让？
我只能苦苦求情，然后跟他说我多么想要上这么多，我下学期要留点空间，我去美国要适应。
不就超了1个学分吗？也就1个小时呀。
22就几乎不可能了，好吧？
哦，你是22个学分，不是21个呀？
不是，我是21，21还有可能，22是几乎不可能。
哦哦，有这么复杂吗？哦，是吗？
你去群里听一下张歆艺的悲惨遭遇吧。
哦，对，我还没看手机呢，我等着那个谁进来。哇，这么长！
那个来了，我在群里叫你。
好，可以。我来听一下，我可以放出来吗？你可来我就马上关掉。
我在上个礼拜，就是大概礼拜4、礼拜5吧。然后之
没事，
前我本来
没事，你听吧，我知道发生了什么。
哦，你们俩已经私聊过了是吗？
我们是一起熬夜把这个事情给崩溃的人。
是 CMR 吗？所以是
不是，是他的教育学。但是那天晚上，哎，
哦，你帮他做作业吗？
不是，就是那天晚上，
啊，你
就
说呀。
就我们都问学姐问题，结果大家都获得，正好大家都同时收到邮件，然后就都获得了一些崩溃的消息。
啊，啥消息啊？
他教育学太麻烦了，他在国内他还是实习，但他又不能去明尼苏达，但他如果今年不实习，他就得多学一年，但是他又不想，那他就只能在上海找个学校实习，但上海学校实习又不太可能，就
我操，对啊，这怎么办？
他还要找3个老师帮他写推荐信，但关键是3个老师还不能是教育学的，但他倒是而且必须是莫尔斯的，他到莫尔斯来才多久？
这也太麻烦了吧？对啊，这才多久？这才半个学期啊！
所以就
为什么这些消息就是刚开始的时候，就是他们都没跟我们说啊？就是老师，哇，太麻烦了。我们是15分上课吗？哎呀，人呢？是15分上课呀？怎么你还没来？
Okay. Can you hear me at home? Good, thank you. Sorry, I'm running a little late. I got here a while ago, realized I didn't have my phone, which means I can't two-factor authenticate, which means I couldn't log into anything. So I had to run home, get my phone. You don't care. But here we are. So, plan for the day is, first, if there are any questions, that, especially questions that relate to the sound collage assignment that's due Friday. We can spend as much time as people want on that. Otherwise, we will actually jump forward to chapter 11. So we're going to skip some chapters and leap up to chapter 11, which returns to strings. So this will sort of return to things that we talked about with strings way back in chapter 3, I think it was, where we did stuff with strings. So we'll come back to strings and do some more stuff with that. And I'm in the process of trying to rearrange some things about the end of the course, where we've been running a little slower than normal because of being online. And so there's some things we're going to have to cut. And I'm not sure exactly what those are yet. So don't necessarily look too far ahead on Canvas, because I think that'll start to be less and less accurate. But if you've got a bored moment, read chapter 11. That'd be awesome. So are there any questions about the exercise, the sound collage exercise due Friday? I am here to help with that. Going, gone. Okay, then we are going to contemplate a little puzzle as a way of motivating some string manipulation issues. So, and I should say, oops, wrong thing. I'm going to share my Blackboard so that I can, my whiteboard, sorry. So imagine, so let me say a little bit about puzzles. So people often do a lot of puzzle stuff in computing. And sometimes this confuses or surprises people. But in some ways, solving computer problems is often a kind of puzzle solving. And in fact, even large things like building air traffic control systems or inventory control systems or whatever come down to a long sequence of small puzzles in a lot of cases. Like, okay, that's pretty obvious. I know what to do. I know, not clear what to do here. And that piece of it, right, assuming we break the big problem down into little parts, some of the parts are obvious. We know, oh yeah, that's like a thing we've done a dozen times before, no problem. But the interesting parts often have the form really of small puzzles. And often puzzles that you see in the real world, like that on, puzzle websites and things like that, programming competitions, since we just did one of those, are often inspired by puzzles that came up in real problems. And so puzzles are a useful way of thinking about problem solving and often can help highlight techniques and ideas that are really helpful. So we're going to do the following little puzzle. So imagine, oops, hello, over here. Oh, there we go. That's little. Imagine we have the following 5x5 block of text. Okay, make sure I get this right. RALNWEAYEO IMHRN DJUKELESDG. And we need to find a sequence of 5 5-letter words, okay, that use all the letters, don't overlap, and are contiguous, i.e. letters are adjacent either across, vertically, or diagonally. So we could have a word that was like RAEMH. Now that's not a real word, but that would, see if I do drawing and so if we did REAMH, that could be a word. I mean, it's not actually a word, or SKNEL, right? That would be legal as a 5-letter word. It's obviously not a word, but if it were, it could count, okay? And there's one other important piece of information, which is the first letter of each word. Write this down correctly. Okay, let me rephrase that. So don't confuse things. The 5 words begin with 5 consecutive letters of the alphabet. So we don't know which 5 letters, but we know that, like, if the first word started with A, the second one started with B, and then C, and then D, and then E. If the first word started with P, the second one started with Q, R, S, T, okay? And so that actually turns out to be a very useful clue, that each of the words starts, that the 5 words start with consecutive letters of the alphabet. Okay. So now that's sort of a complicated statement. Are there any questions that people have about that statement before we actually try to do stuff with it? Yes.
By the word contiguous, you mean next to each other?
Yeah, so the letters have to be next to each other horizontally or vertically or diagonally. And the words have to, the next word has to start adjacent to where the last word left off. So somehow my lines went away. So let me actually do this again. Oh no, my lines are, that's weird. Okay. So actually, but let me undo. Oops, no, redo. Want that. Let me. Can I erase the line without erasing the text? Oh yeah, I can. Oh, bad idea. Undo, undo, undo. Bring everything back. Thank you. So let's actually think about 2 adjacent words. Let's imagine that I have RALAH, that's my first word. My second word might then be, it can start with anything adjacent to the H. So it might be YEONE. Okay. And then the next word would have to start with something adjacent to that E. Okay. Does that make sense? Now, obviously, Rala and Yona are not words, so this is not part of the solution, but hopefully this helps illustrate what's legal, what's allowed. So does that answer your question, Joseph, about adjacency? Other questions? Questions at home? Or questions here? So let us think. So one thing is like, well, how can we use a computer to help solve this puzzle, right? We can just do it, right? But this has a feel of something where we might be able to automate some of the process, because whenever there's a problem that involves some brute force searching, just some hunting around for things, computers are often way better at that than people. And in some ways, this is not unlike code breaking, right? We're trying to find a message that's hidden in some way in a block of letters. And there are a lot of possible combinations, and the computer, well, the number of combinations helps obscure the answer to humans, but computers are good at like grinding through a bunch of stuff. And so they can actually be very helpful as a way of helping us solve this kind of problem. And one of the 2 or 3 earliest computers or proto-computers, a thing called Colossus, was developed in Britain specifically to help break German submarine codes in the Second World War. The Germans had a code called Enigma that was, they believed to be completely unbreakable and was in fact very difficult to break. And Alan Turing and a group of other very smart people built this thing called Colossus, which they were able to use to break a lot of those codes. And that proved to be actually very instrumental in the Allied success in the war in Europe. And so that was a much fancier version of this problem in some ways. Okay, so questions about this before we actually talk, like go to Jess and try to make something happen? Now I'm gonna, while I still have it up, I'm gonna say RALNWEAYO. So you can't see what I'm doing because I need to have 2 things visible to me at the same time. So I'm just typing in the letters into Jess. Now I will share Jess. But I needed to make sure I got the letters right. Okay, so there's our block of words. Okay. And, oh, actually, so the first thing I was going to focus on here is thinking about the way this problem's written. And actually, I'm going to be bad and I'm going to hop back over to the whiteboard. Trying to think about like, how might we use a computer here to be useful? You could try to have a program that looks for words in this. That's actually kind of a pain in the butt, because we've got to have the computer has to know what a word is. It has to recognize that French is a legal 5-letter word in English, and that Yona is not, okay? That's not a trivial thing. We can solve it because there are dictionaries, there are files of lots of words available online, and we could use one of those and have the computer look at all the 5-letter combinations and look them up in this big dictionary to see if they're there. And if they are, then it's like, ooh, it's a 5-letter word. And if it's not, then it's like, oh, no, not that one. So we can do that, but that's actually going to be kind of difficult. And I don't want to actually get into that swamp right now. However, the last clue that the 5 words begin with 5 consecutive letters of the alphabet, that actually turns out to be pretty useful, because there aren't that many sequences of 5 consecutive letters of the alphabet in this block. There's only 25 letters. If they were all unique, we might have quite a few, but they're not all unique, right? There's a couple of A's, and there's a couple of E's, and there's a couple of D's, and there's at least 2 R's and at least 2 N's. Actually, there's 3 E's. So we don't have 25 unique letters. We probably have more like 10 or 15. And so the number of 5-letter consecutive stretches that are even possible probably isn't that large. And it's not that hard to use the computer to take these letters and say, what are the 5-letter consecutive stretches that exist? And then that would tell us what first letters to start looking for. And that's actually going to be a lot easier if it turns out that R isn't part of a consecutive stretch of 5 letters. We don't need to look for a word that starts with R because we know that won't be what happens. If W is not part of a consecutive stretch of 5 letters, which it probably isn't, then we don't need to worry about letters that start with the word, words that start with the letter W, right? So I want to start by just trying to find what sets of consecutive 5 letters exist in this little pot of letters, okay? Does that make sense? Questions about that at home? Okay, so let's go back to Jess. Okay, so here's our block. So now the first thing we need to do is we need to turn this into a single set of letters so that we can try to think about how we might look for duplicates and runs in this. So right now we've got a list of 5 strings, and we really want one string or one list of characters. It doesn't really matter much which way we want to think about it, but we want one collection that's got all the letters in it. So we want to concatenate strings. So the idea here is that sort of we're given a list of strings and we want to return a single string containing all the letters in the given string. So as an example, concatenate strings, this, that, frogs, could return this, that, frogs. Okay. Does that make sense? Questions at home? Questions here? Okay. So, how might we do this? Anybody have a suggestion how we could join these things together? Joseph.
Right, so I think there's a function called string of join.
There is. So do you know what it does and how to use it? So Joseph's suggestion is that there's a function string.join. Do you know how to call it? What it looks like? And it's fine if you don't. I'm just curious if that's done. Okay, so there is a join function built into Python that's perfect for this problem. And if you think about it, this kind of problem is actually pretty common, where we've got a set of strings and we want to bring them together into a single string. Often we want to actually bring them together with some kind of separator between them. So if we look at my example here, right, I get this, that, frogs with no spaces. If we were doing kind of actual text building, we would often want this to have a space between them. We don't here because we don't want spaces, but in other circumstances, you could imagine you'd want this space, that space, frog, or maybe you want a new line between each one. So this, next line, that, next line, frog. Or maybe commas, this comma, that comma, frog. So this idea of joining things together with a separator is actually really, really common. And Python gives us a join function that is built exactly to solve this problem. Now, there's no reason that you would necessarily know join exists. How did you run across it, Joseph? Just Googling around or? Yeah. Yep. So Joseph had just been looking at the documentation for Python for strings and found it there. So good thing. So yeah, it does exist. And how it works is a little odd when you first see it. So it actually takes a string, which is the separator, dot, and so this returns to that business about dots and methods versus functions from Monday, today's Wednesday. Dot, the join string, dot, and then as an argument, you provide the list of other strings. Oh, hello, that didn't work. Oh, I left out the word join. Well, that kind of matters. I had no verb, and if you think about the noun.verb idea, I had left the verb out, and it was like, what? Okay, that's better. So it takes the strings in the list that are passed as an argument to join, and it puts the string that is before the dot between each of them. So it's sort of an odd way to call this, but this is how it's done in Python. A decision was made decades ago, and we get to live with it. And this could be space. I like CSci 1201. Okay. It could be something complicated and big. We've just been doing single character things, but it doesn't have to be. So it could be and join this, that, the other, this and that and the other. Okay. So it just takes whatever string we provide here and inserts it between all of the strings that are provided in the list. Okay. Another option is just to provide the empty string. Oops, I forgot to put that in a list. It's not in a list. It's going to shout at me. So if I provide the empty string, it puts nothing between them and joins them all together. And that's what we want in this instance, is we'll use join with nothing, the empty string, as the separator. And that will allow us to take the whole list of strings and bring them together as a single thing. So that was a lot about join fairly quickly. Are there questions about join? Oh, I think I may have had the microphone on this laptop muted through the entire class up until now. If anybody has been trying to talk and I have not been hearing you, that would be why. I'm not ignoring you. But I've turned up the volume now, so I think we can hear you if you actually speak. Has anybody had a question that I've been ignoring because I'm a bad person? You good? Okay, cool. Okay, so that solves the concatenate strings problem. You can just do that. So that joins up all our strings into a single string. One could even argue we might not need a function. We could have just used join directly. But I think unless you're familiar with join, it's not terribly obvious what that does. And so giving it a name that says what we're intending to do probably has value here. I'm going to save and let's run just to make 100% sure everything's looking good. CSci 1201, 2020, 10. Today's the 21st.py. load the program, concat 10a strings, University Bloop does that. And if we hand it our block, we should get huzzah. Okay. So we've gotten so far as to join everything up into one big string. And that's sort of all we've accomplished so far. Are there questions about what we've done so far? About join, about the puzzle, about sort of where we are in the problem at the moment? Now, I want to write a function, unique characters, that takes a string and returns a string with just the unique characters, i.e., if the letter E appears 8 times in the input, it should only appear once in the output. Order doesn't matter. So, for example, what do I call it? Unique characters? Yeah. Trying to think of. Well, actually, let's do characters because there's some nice repetition there. So that should have return a string with 1C, 1A, and one of all the other letters. I think C and A are the only repeated ones. So it might be C-H-A-R-T. Oh, R is repeated. So that could be it. But I said order didn't matter. So it could also be R-A-E-T-S-H-C. Okay. So we're just trying to remove duplicates. And that's, if I can do that, and then I can sort them, then I can look for string sequences of 5 adjacent letters pretty easily and not have a bunch of clutter from having a bunch of E's or a bunch of R's. Okay. So now the question is, how do we do this? Okay. Anybody have any bright ideas on how we might deal with finding duplicates? I can think of at least 3 different ways, one of which uses something we've never talked about, one of which would be a bit of a stretch, one of which is actually pretty straightforward and uses stuff we covered in chapter 3. And there's almost certainly ways I haven't even thought of. So, Joseph.
Now what you have to do is to have this split of everything, so that you can have an individual letters.
Maybe. So what would you do with the individual letters? We're not worry about the split right away. Let's think about what you would do with the letters. What would you do with the letters?
So then we can specify the indices of the letters, then we can find the letters.
So when you say specify the indices you're talking about like looping over the positions in the string? And how would you decide if a letter repeats itself?
You have to specify a letter but then you look through the string and see it. I think it's more practical. I can do it.
Well, I think Joseph's got the right idea. So the place where Joseph's getting kind of stuck is saying, like, how do you know if a letter's in the string? And there's a trick from chapter 3 that does that really easily, but you may not remember because it's been a long time. And we can use in. So if we ask the question, E in McPhee, it says true. X in McPhee says false. So we can use in to check if a letter is in a string or not. And so we can use that if we have a little bucket of the unique letters that we've seen so far, and we loop over the letters in the string that we're looking at. For every letter, we say, is it already in the bucket? If it is, then we don't put it in the bucket because we don't want two of them. We go bloop, and we get rid of it. Well, we just don't do anything with it, really. And then we move on to the next letter, and if we say, is that in the bucket? If the answer is no, then you're like, oh, that's a new letter. We haven't seen that one yet. And we'll put that one in the bucket. And then we'll move on to the next letter. So we can use a for loop to go through all the letters. And for each letter, we're like, are you in the bucket? Nope. Then I'll put you in. Yep. Skip you and move on to the next letter. Joseph. What? Yeah, we return what's in the bucket at the end. Because that's the set of things we had. Everything that's there will be in the bucket exactly once. So if E is in the string 3 times, the first time we see an E, we look in the bucket and we're like, are you in the bucket? Nope, put you in the bucket. The next time we see an E will be, are you in the bucket? Yep, skip it. And then the next time, are you in the bucket? Yep, skip it. And so at the end, there'll be one of everything in the bucket, so we can return the bucket at that point. Does that make sense? Questions about that at home? Anybody? Okay. So we're going to have result is initially just going to be the empty string. That's going to be our bucket of things that we've seen. Okay. And then we're going to want to loop over the characters in the string. And we want to see, is the character C in the result already? And if it is, we kind of just don't do anything. So what we really care about if it's not in the bucket. So if not C in stir, then C is a new character. We're like, woo, 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 super excited. And we want to put it in the result. Questions? Okay. Then let's see if this works. Save, load. Oops. Made a boo-boo. you are completely correct. So Zeke just pointed out that it should be C in, not C in result, not C in stir. C in stir is guaranteed to always be true, right? Because we're saying for C in stir, C is always going to be in the string stir by definition. That means this is always true, which means this is always false, and we will never put anything in result. So that's why I got an empty list. So Zeke is completely right. The idea is C in the bucket, which is result, not is C in the string, because that's a totally uninteresting question to ask. So that is almost certainly the problem, or a problem. Ho-ho! So it's interesting there. All of university and of were unique. Once we'd seen one space, it didn't give us any new spaces. Capital M was unique, but I, N, N, E, S, O, and T we had seen before. And then the A at the end of Minnesota was new. And then all the letters in Morris were repeats, and so got removed. University of Maine. Okay. And so questions about unique characters. And I think this is probably the simplest way to do this, especially given the tools that we've already talked about. You could, there are some other tricks you could use. There is a thing called a set. And a set gives you a unique collection of items. So if you think about sets from like math, a set only has one copy of anything in it. And so set is a built-in data type in Python, and you can use it to uniqueify a collection of things by just turning it into a set. So if you give it a list, and a string is essentially a list of characters, and you say, make that a set, then it will give you a unique list of characters back. The order here is kind of random looking, and that's somewhat unavoidable. It's a property of using sets that you don't have any guarantee about the order. But that's an easy way to turn a group of items into a set if you want to do that. And so we could, and notice it's still got this set thing in front of it. If we said we want to turn it back into a string, oh, stop it. I think we could do this. I know we could do a list, but I think, oh, no, that was not helpful. Let's make a list instead. So that would give us a list of characters, and then we could take that and join it with the empty string as the join, and we would get, we could turn it back into just a string of the unique characters. And that is actually the same as University of Ma. It's just in a very strange order. So we could do that to do unique characters. We could use this set idea. There's a lot of different ways we could do this. The set approach would probably be slightly faster if you had very long lists, but you have to have quite long lists to be able to tell the difference. I think you'd probably have to be I would guess into the hundreds of thousands of characters before you'd probably be able to notice that there was much of a difference. Which, you know, on the one hand is a lot. We're not likely to have 100,000 characters to work with anytime soon. On the other hand, if you're doing large scale data mining in sort of big data, or if you're the university dealing with huge numbers of students or something, 100,000 is not that big a number. People doing this sort of in a big way often deal with millions, billions of data items. So there certainly are people who would care about the difference. We would be unlikely to see it here. Okay. And actually, let's just, for fun, let's do the set version just so that we have it on the record. So same as unique characters, but uses Python's set data type to the so that takes the string, turns it into a set of unique characters, turns that back into a list, and then joins that up with the empty string to give us a string back at the end. So now we've got that as well. You can make sure that that works. Set unique chars University of Minnesota. Okay. So we've done a lot. Questions? Before we actually get to the business of finding which runs of 5 characters there might be in our block of letters. Going. Okay. So now that we've got that, we can actually say unique char characters. What do I call it? I think I called it like block or something. Block. A block. Okay. And that's not right, because that's got. Oh, you're right. I've got to first join it together using concatenate strings. Well done. Ah, that looks better. Okay, so there's our unique set, and it is definitely smaller. Okay. In fact, we could say, how long are you? So it's got 17 characters versus 25 in the full thing. So we removed 8 characters. So then the question is, did we get lucky, and are those 17 characters spread out enough that there aren't a lot of unique, or not a lot of separate sequences of 5 consecutive letters? Now, at this point, like, we could try to figure out what the consecutive letters are. Like, we can see there's an A. You can look through and see that there's not a B. But it'd be a lot easier if we could sort these. If this was in alphabetical order, man, this would be a whole lot easier to look at. Turns out there is sorting. So turns out that sorting is actually one of the great problems of computer science. There's like a handful of like really standard things that you use all the time and that have been studied a great deal in the history of computing. And two of the main ones are sorting and searching. Searching is given a pile of stuff, looking through it for something that matches what you're after. And that's important. You know, if you log into register, like it's, you know, we're approaching registration time, it needs to find you based on your login, your X500, and not all the other tens of thousands of people that are using the system. So that's a searching problem. Sorting is what it says, right? You've got a bunch of data, you want things to be in order. And the two are related because if things are sorted, they're often easier to search. So that's why we often keep things in numerical or alphabetical order, because it makes it easier to find something quickly than if they're in a completely random order. So sorting and searching are actually not quite two sides of the same coin. That might be joining them a little too strongly, but they're definitely like cousins that see each other a lot at family reunions, right? They end up together a lot of times. And so sorting is actually like a really, really useful thing, okay? So let me check one thing quick. Okay. So, and it turns out that sorting is another one of these dot things. Whoa. Or not. Or not. What have I done wrong? No? Oh, does it not know how to sort strings? Do I have to sort lists? I feel like this might be an old Python versus new Python problem. Oh, yes. Okay. That's the problem. Okay. So let me actually back up and explain what's going on. So, so there's nums. It's a list of numbers. If I say nums.sort, it looks like nothing happened. Turns out it sorted nums. And it didn't return anything new. It just sorted nums sort of behind the scenes and left it changed in the thing. You can't do that with a string because you can't change strings. Strings are immutable. So for this to have made sense, it would have had to have changed the string. If we had a list of characters, though, so actually if we had Nick McPhee dot split, whoop, no, that didn't work. Well, here, we can make a list out of it. That'll be easier. List. So if we do this, we should get a list of characters. Yep. Now, so if we say letters equals list, Nick McPhee, letters dot sort, letters, and they're in alphabetical order. Turns out that space comes before all the letters, capital letters come before lowercase letters. So that's why the space is at the front. Then we have M and P, which are in alphabetical order amongst the capitals, and then C, C, E, E, H, I are in order amongst for what the little letters. Joseph, you had a question. Yeah? You think this, when I try doing this, sorted will work? Really? Okay. Oh, well done. I didn't even know that existed. Go, Joseph. Thank you. So there is a function sorted that takes, does it just take a string or does it also work on like lists of other things? Ah, takes lists of things too. Rock and roll. I had no idea. Good job. So we could use either way. So this is interesting because here we have a function and we have a method form. So sorted is a function that can take a list of things and sort it and return it as a new list. And the method, the dot sort version, only applies to lists, does not apply to strings, and does not return a new thing, but modifies the sequence in place. So those are rather different ways of thinking about those two ideas. They both ultimately accomplish the same thing, but they do it in ways that are rather different. So that's kind of cool. Well done. So that means if we come back, actually, we're typing a lot down in the bottom. Let's actually sort def sorted unique letters. It's going to take the block and it's going to, actually, let's use this sorted thing. Sorted unique characters. Actually, I probably ought to call this characters to be more consistent. Unique characters of concatenate strings block. So that should give us a sorted list of unique characters in the block, he says, hopefully. Let's see if it works. Aha! That is a sorted unique list if I ever saw one. Okay? Questions? Now, looking at this, A jumps to D. There's a gap there. D, E, we're missing F. G, H, I, J, K. Okay, there's a string of 5. And it continues, actually. So L, M, N, O. So those are all in order and consecutive. Then we skip P, R, S, we skip T, U, we skip V, right? So none of the rest of these can be part of it. So we know that the starting letters have to be some sequence of 5 things, consecutive things from this list. So it's GHIJK or HIJKL or IJKLM or JKLM, KLMNO. So there's 1, 2, 3, 4, 5 options. So we've gone from 20-something options for 5 letters in a row to 5 options for 5 letters in a row. So we certainly reduced the possibilities by quite a lot about where the starting in of the 5 words might be, okay? So now it would sort of make sense to maybe look for words that start with these letters in the block and see if you can then sort of go somewhere from there. And in particular, like, let's see, GHIJK. So K has to be there. It's the last one starting with the G, and it's the first one in the last 5. So there's got to be a word in the block that starts with a K. And you can kind of then work out from that if you needed to. But this would give you sort of a lot of useful information about where to focus your attention. And since I assume there's only one K, yeah, there's only one K in the whole thing, starting there and looking for like where could you go from there would be a reasonable way to sort of start the puzzle. And you would know that there's got to be a word that starts with a K, and that, you know, everything's got to like extend from that either forwards or backwards or both. So that would be a pretty useful hint. Okay. And I will not attempt to solve the puzzle right now. I will leave this as an exercise to the reader. You've got a pretty useful starting point, but unless we were to try to load up a dictionary, the rest of it's not really computer science as much as just a human being staring at things. And I'll let you be the human being staring at things. Questions? Got another thing to talk about for strings and lists that's related to this, but I want to see if there are questions first. Going. Okay. So one thing we've done in concatenate strings, we took a bunch of strings and we turned them into one thing, one big string. Another thing we often want to do is take a big string and cut it up into pieces. And there's actually a very powerful tool in Python called slices. And a slice lets you get a subsequence of a list or string, because they're kind of the same thing, by specifying the start and end point of the slice. So as an example, I'm going to come down here for a second. So let's say we've got, let's make a string, spelled Minnesota. We can say U 3:7, and that says give me the slice of that string that starts at position 3 and goes up to but does not include position 7. So 0, 1, 2, 3. Oops, I totally failed to do that the way I wanted to. So that's 3. And then 4, 5, 6, that gets us up to but not including 7. So VERS should be what we get back, and it is. And we can be like 7 to 15. And we get ITY space OF space M. And I'm not going to do all the counting, but I will trust that that goes from 7 to 14. Okay. You can do some cool things where you say only provide one side. That says give me the first 10 things. I didn't actually realize that was going to be on a word boundary. Let's do 5, just so it's a little clearer. Give me the first 5 things. You can say, give me from 5 to the end. Okay. And so if you leave off the first one, it'll start at the beginning. If you leave off the last one, it'll go to the end. You can do some kind of crazy things with negative numbers. You wouldn't think negative numbers would make any sense here, but they do. Let's see, we'll do that. -3 says end 3 before the end. So go to 3 short of the end. So that leaves off the last 3 characters in Morris. Okay. And so you can use that to, like if we wanted to drop the first 5 and the last 5 letters from a string, we could do that way. Get rid of the first 5, get rid of the last 5. Okay? So you can use slices to do some kind of nifty things. They're actually very cool. Okay? And so a question that we might want to, we only have 3 minutes, so we won't do this whole thing. But if we think about where we had block and concatenate strings, block, how would we do the reverse of this? If you were given this and you wanted to divide it into chunks of 5, how could you do that? And slicing would be a great way to do that. It would make it very easy to say, give me 5 characters starting at a particular point, okay? Because if I have u 0 to 5, I get the first 5 characters. 5 to 10 gives me the next 5. That gives me the next 5, et cetera, et cetera, et cetera. So there's a for loop there that could be made that would go through the block numbers essentially and then extract that block, block 1, block 2, block 3, and then you can put them together in a list, and that would let you reverse this string concatenate function and go back to the blocks. And that's actually pretty important. If you think about the way text wraps in a word processor, like Google Docs or Microsoft Word or something, right? If you think of a line as being 80 characters, okay, it's probably, plus or minus some because it depends on your font size and a bunch of things. But let's imagine as an example, a line is 80 characters. Well, how do you get this, what's essentially a very long string of text to sort of look good in an 80 character column width? Well, essentially you cut it up into blocks. It's a little more complicated than that because you want to break on spaces, not in the middle of a word, right? But you would start by cutting into the blocks and then you kind of come back to the first space and then move the rest of that stuff down to the next line. But it's very similar to this kind of blockifying that we're able to do here with slices. So slices, very cool. You can do some nice stuff with them. And they work on lists as well. So I think I have nums floating around. Yeah. So if I say nums 2 to 5, then we get 2, 3, 4, but not position 5. So strings and lists you can use slicing on and do some very cool things. So, okay. So we got like 1 minute left. Anybody got a question? We covered a lot of stuff today. We good? Okay, well, I will see all you fine folks later. Ciao.